All right, so what we're going to do right now is I'm going to go around the shop here, and I'm not going to give you a shop tour. I'm going to wait and do that because the more that you know, and when I do give the shop tour, the more interesting it's going to be for you, okay? But what I'm going to do right now is we're just going to go around the shop. We're not even going to turn anything on. I'm just going to introduce a couple machines to you and show you how they work, all right? And not how they work, but what their intention is. I think that's the best way. So here we go. Okay. Let's see. This right here is a drill press. All right, and what's in it right now is a single point countersink, which we discussed already. This lever right here moves it up and down while it's on. All right. So the work is typically held in the vise or clamped to the table, and then there might be a drill bit in here, and this is the chuck. The chuck works like this. So you take a chuck key, you loosen this up. So I got one-handed, right? And this comes out, okay? And this is what there's 3 jaws down here, and that's what grabs it. Remember when we talked about the drill bit? We always grab from the shank. We don't want to put and grab by the flutes because it's not going to line up properly. Okay. This is called the chuck. This is called the chuck key. So I'm going to give a demo on this later and how to use it safely, but I just want to show you what a drill press is. This is a pedestal grinder, okay? The reason it's called a pedestal grinder is simply because it's on a pedestal. Believe it or not, it's actually a bench grinder mounted on a pedestal. So if this grinder was on a bench, okay, it would be a bench grinder. So this is a pedestal grinder. My water's empty, but we're going to discuss how important that is right now. It evaporated. This is the tool rest right here. This is the wheel. You can see that there are 2 different wheels. I have a coarse wheel in here and a fine wheel in here. Okay, there's the tool rest. All right, let's keep going. So that's a grinder. Pretty simple, but yet dangerous. All right, so let's keep going. This is the infamous disc sander. I don't know what it is around here, but a lot of people get hurt on this guy. I don't quite know why, but we're going to learn how to use this and use it very effectively by being extremely safe. I think the disc sander is one of the most valuable tools in the entire shop, other than the actual, the big machines. For a peripheral machine, it's almost essential to have one. Use it for flattening material, deburring, maybe a slight material removal, but not a lot. Okay. This is a disc sander, and it's simple. It's just this is the rest, and it has a piece of abrasive or sandpaper glued onto a disc, and it spins around and it sands your material. All right. Okay. This is a band saw. Now, what does it mean by band saw? Well, what that means here is, I'll lift this up, is that there's a blade in here. All right, let's turn the light. There's a blade in here, and it's a flexible piece of metal that it's in a band that goes all the way around. Open this up so you can see the wheels, and there's the blade. This is a beautiful machine. It's a 3-wheeled, but we're not having shop tour right now. But this is it. This is the rest or the table, and the blade goes through. It guides and cuts your material. So this is called a vertical bandsaw. Okay, we'll get into that into real detail shortly. This is another bandsaw, but its configuration is different. So the other one was called a vertical bandsaw. This one you can see down here, the blade is going horizontal. So this is a horizontal bandsaw. You can see the two wheels, okay? This is a horizontal bandsaw. And you actually, on this machine, you put your material in the vise down here, and then this lifts up, and its feed rate, how fast it comes down, its feed rate is controlled by, you can see it's barely moving, it's controlled by a hydraulic cylinder, okay? And then its speed, or in this case in a bandsaw, its band velocity, is determined by these pulleys. These pulleys here. So it has 4 speeds, this particular one. Let's keep going. All right. We're going to go over here. This is a lathe. All I'm going to say right now is that what is typically going on here is, yes, I have a chuck and a chuck. I know that's bad, but I had a thing I had to make real quick. Don't just kind of ignore that. The material is what's spinning, okay? I'm really hesitant to say something round because I put rectangles and squares and anything I can get, anything that needs a hole in it, in here, by means of different chucks and different holding devices. But the important thing to know is that the material is what's spinning, and then the tool, what does the cutting, right, is not stationary. But think of it that way. Think of the tool as being stationary, even though it's not. It's going to be moving along, right, to make the cut. But the material is rotating. So when in terms of feeds and speeds, the speed, RPM, is the material, and the feed rate is the tool. Okay, this is a lathe. Okay. I have designed the lab to be primarily lathe-based. You do use the vertical mill and the drill press and stuff like that, but majority of the time is spent on the lathe because it's so much fun. And I just wanted you guys to have a really good time in lab. So the lab is designed around the lathe. This is a vertical mill. Okay, and it's kind of like the opposite of the lathe. It's not, I'd hate to use those terms, but for the very introduction, like the very beginning, that's kind of how to think of it. In this case, the tool spins and the material is clamped into a vise, and the material is fed into the tool. Okay? All right. And it's called a vertical mill. When we're going to look at this very closely, just like the lathe. Vertical mill because it's vertical. The tool is mounted into the machine vertically. And we're not going to use this machine, but I'll show you anyway. This is a horizontal mill. And you can see the tool is, you guessed it, horizontal. So same principle, you put the material in the vise and it's fed into the tool, and the tool is what's spinning, okay? Which is the exact opposite of that of the lathe. All right, keep going. Here's another drill press. Yes, another drill press. And no shop tour, but here's a beautiful LeBlond lathe that's here. We might get on this. Actually, we definitely will, especially at the end. And here's a small lathe here. All right, so I just wanted to show you what these tools are. And yeah. And we're going to go back over here. We will do demos on all these machines, okay, and all of them. We're going to learn how to use them safely. We're going to know what the parts of the machines are, and really go in depth on how to use them. Okay, great. All right, so real quick here, I'm going to run around the shop with the camera, and I'm just going to point out 3 different machines, I think, or 2 different machines right now, just so we have a refresher about what they are and what they're called, and then we're going to return back to the whiteboard, and I'm going to discuss those 2 machines more in detail. They are the pedestal grinder and the disc sander. So this is the grinder, and remember it has these wheels, right? Let's look at the side here. And what we want to look at real closely is this. Here's the wheel. Remember, it's going to go clockwise, and then there's the rest. I call it a rest. It's also known as a fence. We'll discuss that a little bit more. Here is the disc sander. All right. Who was using that? I don't know. All right. This is the disc sander. This is the rest right here. And this wheel spins like that. Okay. Let's turn that on real quick. Can you tell which direction that's going by this camera? Nope, you cannot. Actually, on the camera, it looks like it's moving the opposite direction than what it actually is. So let's go back to the whiteboard and look at the disc sander. Square it up there. I think so. All right, pretty good. Okay. What we've got going on with the disc sander. Front view, like we just saw. We've got this disc, and on this disc is glued sandpaper. Okay? It's been glued on there, not coming off. Well, at least hopefully not. And here's the, let's just say this is the center. And here's our rest. And I'm going to draw the rest because that's how I like it. Some people don't. Just below center. So here is our rest. Now I mentioned earlier when we did a quick little look at machines, people get hurt on this thing here, and I don't know why. Actually, I do know why. The reason is, number one, is they weren't properly trained or shown or taught how to use it. That is why they got hurt. They walked up to the thing, They walked up to the disc sander and they put a piece of material on there and it blew back on them, and they either cut their finger or it hit them in the chest, it hit them in the face, something happened, okay? Yeah, they had safety glasses on and they still got hurt. Okay, so here we go. This disc is spinning, okay? And we're going to be making it spin clockwise. There's our arrow. And here's our, let's say here's our axis. It's actually, we're gonna discuss this. What's actually happening with a disc sander is we'll go back to this so we really understand what's happening, and what's happening with sanding and grinding for that matter all the time anyway, is the grit of the sandpaper. If we were to go ultra slow motion, all right, not 1300 RPM like that thing's spinning. If we I don't know that, I just made that up. If we go ultra slow motion, what's actually happening is the grit in the sandpaper is grabbing the material and pushing it down onto the rest. Ultra slow. That's what's actually happening. And now the force, or here we go again. The force of this thing spinning around so fast is making the speed, is making that grit cut and slice through your material. But I can't stress it. What's actually happening is that the sandpaper is grabbing the material. I'm overemphasizing, and pushing it down onto the rest. Okay? Which means that what do you think is going to happen if I put the material on this side of this axis? Actually, it's more than that. We're going to enlarge this axis to about over here. Okay? You see that? All right. There are some exceptions to what I'm about to tell you, but that's advanced machining. Right now, I would bet 90% of you have never used a disc sander before, ever, okay? So, for the first year of your life using a disc sander, you are never going to put any material in this area, ever. It's off limits. What's going to happen if you put the material over here? Wham! It's going to go flying off, okay? And I've seen it. I've seen people take a piece of sheet metal that's really thin metal. You guys, a piece of sheet metal, excuse me, I'll be right back. This is a piece of sheet metal, as opposed to a piece of plate. This is a 1/2-inch piece of aluminum, okay? All 4 edges, actually 8 edges, even though you might not think that, and the corners are like razor blades, especially after it's been cut. So if you put this over here, and this goes flying around, and it's all wobbly, and it comes back and hits you in the face, you're going to the hospital. You're getting stitches. If you try and stop it, and it comes in here and right? You're going to get stitches, okay? As opposed to this piece of plate, where if you put this piece of plate over here, it's going to go flying. It might hit you in the face, or flying across the room if it comes out of your hands, which is most likely. You're not strong enough to hold that with the forces involved, okay? The velocity is just too intense. We need this rest. This piece of sheet metal that I grabbed, and I grabbed on purpose, this is too thin for the disc sander, okay? There has to be, so if we look at the top view, and here's our disc, okay? There's our disc, and here's our rest. I probably should have switched the colors, but that's okay. There is a space between the disc and the rest in there, and it should be less than 1/8, okay, but it's roughly 1/8 of an inch wide. This piece of sheet metal, I don't know what gauge it is offhand, but this is like a 32nd of an inch thick, okay? It's highly likely that if I put this up there, that it's going to get sucked in between the disc and the rest, which means this thing's going to go, whoosh, okay? It's going to slide through there violently, like very violent. And you're holding this, okay, like this, what's going to happen? Okay? Which leads to another safety thing, and we'll continue a little bit with the disc sander, but no gloves are allowed in the shop. I know that. Today there's been a couple. I've been digressing. I do that especially in class. Gloves are not allowed in the shop. There's only two instances where gloves are allowed in the shop, and that is when either you're welding, okay, absolutely welding gloves, or you're handling raw materials. For example, you're unloading a truck and putting them in the stock room, or possibly you're taking them out of the stock room and placing them on a table or a bandsaw where they need to be cut. Handling. That doesn't mean you can wear them when you're using the bandsaw. Gloves are not allowed in the shop. This is a rotating piece of machinery, and so is the grinder. If a tip of a glove were to get caught in the space between the rest and the disc, what's inside that glove? Your hand. They're simply not allowed. I understand that working in a shop or even doing things with your hands, you know what, isn't for everybody. And that is totally okay. Okay? It's just not. It's not for everybody. It's like writing novels isn't for everybody either. Okay? It doesn't mean that you can't work in a shop and be successful. That's not what I'm saying at all. It just, if you're afraid to get dirty, and you don't want to get dirty, or your hands to get dirty, or, you know, then the shop just is not for you. I use the novel I couldn't write a novel. I could do it, you know what I mean? I could do it. It's not going to be very good. It's going to be awful, right? Same thing. You get it. Okay, so gloves are not allowed in the shop, period, unless you're welding or handling material. So let's go back a little bit to some rules on the disc sander. All right. I can erase this now. I think we all have vision of what this is like. Grab one of my fancy towels. All right. Get rid of this. All right. Rules for the disc sander. And some other rules for the shop. You can hear something going tick, 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 tick right now, I think. And that's the disc sander spooling down. You might have noticed that it has probably taken, and I really like that. I mean, it's taken, what's this say, 6 minutes. So it's probably taken a good 15 minutes for that disc sander to spool down. When I mean spool down, I mean after I turn the power off and for it to stop. In the shop, you never walk away from a machine after you turn it off until it has stopped, with the exception of the disc sander. Okay. The reason for that is that it could take 20 minutes for that disc sander to stop, and that's an awfully long amount of time to be waiting and standing there staring off into space doing nothing. But every other machine or piece of equipment, power tool, hand power tool, anything, You never walk away from it until it's completely stopped, except for the disc sander. When I showed you the disc sander and I turned it on, and I said, look, it looks like it's going the other direction, just like when you're going on the freeway and wheels are spinning, right, at our whatever RPM they're going. The car's going 75 miles per hour, and they look like they're spinning backwards. That moment, when you turn on the sander or any other equipment, you've got a millisecond. And that's exactly when you want to pay attention to which direction that wheel is spinning. I think that makes sense. And when I demonstrate, I'll show you that more clearly. But you've got that fraction, those milliseconds, right when you turn it on and it starts to spool up, okay? That's when you can tell really what direction it's spinning. When that sander's on, it's really hard to see which direction it's spinning, okay? And you need to be really careful, because if you put material on the wrong side, you know what's going to happen. Okay. So let's talk about a couple rules real quick about the disc sander. All right. Let's take a 2x4, for example. And here's our 2x4. And we want to make it like this, with a hole in the middle. So you've been around the shop for a couple months now, you got some chops, and you said, oh, I'm going to drill the hole first. And yeah, you're right, you drill that hole first, and now you need to round out this. And you might say to yourself, oh, I'm going to go use the disc sander. No, you're not. Removing this material here, all of it, that is what's called free hand sawing. And it is not allowed. All right? Let me tell you why. Okay. First of all, that's a lot of material to remove, believe it or not, from the disc sander. And what's going to end up happening is you're going to end up wearing out the disc prematurely, okay? Which is going to be a drag for your fellow students, number one. It's going to be a drag for the shop stewards, the technicians, because they have to constantly change the disc, and it's going to hurt the budget. And in any shop all over the entire world, freehand sawing is not allowed, not just here, just letting you know, okay? And that's why. But let's analyze really why. Okay, so as we start to sand, if we were to not, okay, I'll cut to the chase. What you're going to want to do is cut this off first, and then clean it up on the disc sander. The disc sander is for cleaning your surface, removing saw marks, and deburring. It is not for shaping. We use a saw or a cutter for that, okay? Where I was going was, let's look at why. You go up with your 2x4 to the disc sander and you start to sand off this corner, right? Well, it starts to go real quick. And you're like, oh, no problem. And you keep on going, and now all of a sudden, things stop going so fast. You've generated a lot of heat. And look at the surface area difference between over here and over here. It's much, much exponentially greater. Okay? So I hope that explains why freehand sawing isn't allowed. what does end up happening is you generate a lot of heat. If it's wood, your material will start to burn, actually, and you're going to wear out the disc prematurely. If it's metal, you're definitely going to wear the disc out. Like, you're going to be, to do that with a piece of metal, you're going to go through like 3 discs. Discs are probably 12 bucks now, right? So just to do that with a piece of metal would be, how much is that? 36 bucks, okay? And it's going to get too hot to hold, which then I'm going to go get a pair of gloves. Nope. Okay. So there's some general guidelines for the disc sander. I will give a demo next for sure on how to on the disc sander, so you will know exactly what that looks like. All right. Okay. Next is, after I get this cleaned off, is the grinder. So I showed you the side view of that grinder wheel, very much intentionally. So let's look. There's the wheel. Okay. And I think, yeah, we'll put the rest over here. Here's the rest. The rest in. Okay. Now what I want to do is I want to divide this grinding wheel into 4 quadrants. I think that's pretty visible. Okay. So let's look at these quadrants, these 4 individual quadrants. Okay. So this is the front over here, right? There's their rest, where you're right. Okay, there you are. Obviously, this is completely off limits. This is completely off limits, not because you can't use it, but because you can't even get there. Okay, it's impossible to reach, and typically gets covered up by a guard, but we'll draw the guard at the end. This is off limits. Why is that off limits? Well, you can't get there because the rest is in the way. So that leaves this number 2 quadrant here. All right. Now, the grinding wheel is coming down like this. Remember, it's going clockwise. You probably still hear that disc sander. Tick, tick, tick. Okay. Same principle applies with the disc sander. The grit of the stone, the grinding stone, is actually grabbing that material and pushing it down onto the rest. Okay? What is going to happen if you just hold your material up here and start grinding? Boom, 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 boom. You're going to be doing this, bam, 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 bam. That's not good, okay? What's going to happen if you hold it like this? It's going to shoot, right? It's going to shoot this way because the wheel's coming down this way. So it's real important that that you rest your material on the rest. The space between the wheel and the rest is never ever more than 1/8 of an inch. So it's never more than 1/8 of an inch. Okay, 3/32 would be ideal, but the grinding wheel wears out over time. So you're gonna have to adjust and move this in as the grinding wheel wears out. There's one exception to what I just showed you, but it's for welding only. It's for working on the tip of a welder, but we're not even going to go there. So if we look at this, and now I'm going to draw a guard on the grinder. the guard that's the guard. This whole thing, so the only access is here, okay? I hope that helps make sense. You're gonna notice on a grinder too that next to it or in front of it, just like the grinder I showed you, was a bowl or a cup of water. All right. Yep. You've got to use the water. I see it all the time. Especially in winter when the heater's on. The water has evaporated and you go up to the grinder and there's no water in the bowl or the cup and you decide you're going to use it anyway. Well, you can't do that. Just stop. It takes 30 seconds to fill up the water. You go fill up the water. The motion for it, and I'm going to tell you why in a minute. The motion, and when I give you the demo, you're going to see even more, is timing-wise is like this. I'm grinding. Dunk. Steam, right? Dunk. And you're going to do that while you're grinding. What happens if you don't do that? Well, here at school especially, we typically buy not special, but we buy metal that is the right alloys, the right kind of metal for our projects. So if you heat it up and it starts turning orange and purple on you, you're actually ruining your metal. So the piece of metal that you bought from McMaster Carr for $15, right, whatever it is, whatever, high-speed steel or 8620, whatever it is, and you heat it up that hot, you're ruining the properties of that metal. You're turning basically into scrap metal. You might as well just pick something up at the junkyard or the side of the road. Okay? And then number two, it gets too hot to hold, which leads to, I already said it. Okay, so that's primarily why you use the water. Now, some other rules besides what I showed you. Really, the only thing that you can grind on the grinder here at the school that we typically use. I mean, there's lots of things that industry you grind in industry, so that we're not gonna go there right away. Oh, this is not good. Okay. The only thing you're really gonna grind here at the university is steel. Obviously, you can't grind wood on a pedestal grinder. That's not going to work out so well. I think that's pretty clear. But a lot of people, and I still see it to this day, I'll walk into the shop upstairs on a Monday morning, and guess what? That grinding wheel's filled with aluminum. So I'm going to write it. I'm going to write it in black, though, so I don't have to. Absolutely no aluminum on the grinder. Okay? No brass. No plastic. Any kind of plastic. I don't care what kind of plastic or what you say. I got this special. No, no plastic of any kind. No wood. Okay, it's just going to burn the wood anyhow. The reason is because the chips don't actually chip. They melt. And they stick into the wheel, into the grit of the grinder. And at that point, once it's filled with aluminum, there's no grit left. It's just smooth surface of aluminum. Okay? It melts and it welds itself into the wouldn't say weld, that's the wrong term, but it melts and it sticks into the grit of the grinder. Okay. It's amazing to me that this is like, it's plastered all over the place and people still do it. I hate to say this and I don't want to think it, but I think it's just laziness. And look, I have no tolerance for that in the shop, especially when I'm running the show. I've been doing this, like I said, for 40 years. This is a discipline. If you are going to disrespect the shop that way, then the shop's not for you. And that's just the end of it, period. So no aluminum, no brass, basically no soft materials. And if you go through the list, it's here at the school, it's about the only thing you're going to use the grinder for is steel. Okay? I think that covers the lecture portion of the sander and the grinder. I will let's do some, maybe I can set up and we'll do some demos, all right? All right, so here we are. I got my safety glasses here. I'm going to put these on, of course, and I've got two different pieces of material that we're going to use. And I'm going to see if, yeah, there we go. Now I can see. Okay, good. All right, so I mentioned before that we'll walk up to the disc sander here, and what I'm going to do is the moment that I turn it on, I'm going to pay attention to which direction it's turning. Okay. Now I already know, because this is the shop that I use, which direction this is going to turn, and so instead of walking up to the switch here, I am going to just reach around and turn it on. But because I want you to see this, okay? And I'm going to wait for it to spool up, and I'm going to show you a couple different techniques on how to use the disc sander, and then at the end, hopefully I remember to show you what not to do. Okay, all right, so I'm going to kind of go in here, and you can see that my gap down here is less than 1/8 of an inch, okay? So remember that piece of sheet metal I showed you? That's going to slide right down there, okay? So what I've got here is I got a piece of 1/2 inch bar stock, aluminum, and I've got a piece of a round stock here that's looks like it's been faced on the lathe, but what's most important is this burr around this edge here, okay? Now I could take a file and file this off, should do that, but I'll show you. But I'm going to use the disc sander instead for this demonstration, okay? So I'm going to go ahead and turn it on. I'm going to reach over so you can see. Now normally I would walk up to the switch, remember, but I want you to be able to see this. All right, so pay close attention. It's that split second when this thing turns on, you can see which direction it's going. See that? Right away, okay? Now, you don't know what direction it's going, but we know that it's going clockwise. So what is going to happen if I put something over here? Woof! Gone! Okay? So, I'll put this aside for the time being. And what I'm going to do here is, if you see that, I am going to remove these saw marks. Okay? Right? All right, we're getting there. You can see the striations of that, okay? But that's not what's important. What I want you to watch right now are my hands. This is the magic, you guys. People, this is the magic right now. All right. Remember that the disc and the fence are doing all the work. So look, I am barely holding on to this. Am I white knuckling this at all? Like, am I pushing? Absolutely not. Okay, you guys, this is the golden ticket right now. And this goes for everything. As a matter of fact, for every single machine in the entire shop, there is no exception. The gentler you are, the more successful you will be in the shop. So and you're gonna hear me say this a million times, I am just the guide. I am not the machine. I am just the guide. Look at my hands. You could move them. Okay. See that? We're making a little bit of progress there, but that's not what we're here for. We're here to know that you are just the guide, and this is how it's done. Okay. Now notice that I moved along the disc. I'm not staying in one area, because what's going to happen is I'm going to wear that grit out in that one area, and I don't want to do that. I want to use the whole disc as much as I can. Okay? All right? Saw marks are almost completely gone. Okay? Now you also notice that I'm not using a fence. This device right here, this is a fence. It goes into this slot right here, and it helps you keep your cut square. I don't use it. I know. People are like, what? I know. All right, here we go. I'm going to teach you a completely new way of seeing. Okay? What I see in my mind is a series of lines and planes. I know. Bear with me. Okay? I see this as a giant plane, and it goes into infinity. And I know I probably shouldn't even say this, but see this guard right here? It's gone. I take it off. You know why? Because it's in my way. And nothing is more dangerous than something being in your way. Anyway, we'll talk about guards later. Okay. So I have a plane here, and I've got lines down here that I draw in my mind that are perpendicular. And that's how I see. That's how I see on the lathe. That's how I see on everything that I do. It's just something that comes. You can see. You might say, "Oh, look, that's from." You can see that discoloration there. That's from the fence. I bet that I'm more square than the fence. Okay. And that's it. Now our saw marks are for the most part gone. I'm going to show you really quick how to deburr this safely. I'm not on the fence necessarily. You can be. You got to make sure that your material is obviously wider than the gap, of course. But really, look how gentle I am. Okay, now deburred, right? We can, let me hit this one more time, and I'll get the square out. And we'll see how true this is. Okay, so that's the basics. That's the basics. Let's look at some round material and how to handle that. Okay, so this is actually pretty trued up already because it was done on the lathe. But so first I'll deburr it. If I wanted to sand the face of it, it would be the same process as that bar stock that we just had. So let's just deburr it, okay? But this time I'm definitely going to use the fence. and I'm gonna hold it like this, okay? It's at an angle, see that? Yeah, there we go, right? And I'm gonna do that, okay? So here we go, right? But notice, I'm not doing any work. The machine's doing all the work. Look at, if you can see my hands. I mean, they're just spinning this thing, okay? Look at how gentle. Look how gentle. Look. That's it. I am done. Okay? Facing it would have, sanding the face of it would be the same thing. All right? Look, I pretty much got all that, right? And I'm just eyeballing it. Look at that, okay? For those of you that don't believe me, well, I don't know what to say. I really don't. Okay, and now I'm gonna turn it off. Okay. And unlike any other machine in the entire shop that you need to wait, you can walk away from this. Now, what definitely not to do? Obviously, you don't want to be on this side, right? Because the material is going to go flying. I think that's set in stone. You might be tempted to try and stop the disc sander with a piece of scrap material as like a brake, right? But you can't do that. And the reason you can't do that is because remember how I told you that what's happening is that the grit is actually grabbing the material and forcing the material to the table? Well, as it slows down and the motor's off, it doesn't have the force to slide and cut through that material. What's going to actually end up happening is the material, you're going to end up ripping the garnet or the sand grit off the paper of the disc. All right. So yes, you could apply pressure here and stop this thing, and no, you're not going to get hurt. No, but what you're going to end up doing is ripping the stone out of the sand, out of the paper. And one last thing before we move on to the pedestal grinder. This area right here, this 2 inches right here on the disc, okay? This is the golden area of the disc, okay? So in my shop, yes, the shop we're in, I don't use this area, and I don't allow other people to use this area of the disc unless it's absolutely necessary. This is the golden area. This is the largest circumference, okay? So it runs the coolest. It also gives me access. See how the rest comes around to the side here, okay? See that? It gives me access out here. So really what you want to try and do is use this area of the disc the most. Wear this out the most, okay? Save this golden area of the disc. And before I get into guards and all that, it's never a good idea to remove the guard, but let me show you why I don't have the guard on here, right? Okay, so if I put the guard here and I come around to here to the side, which is completely permissible to sand, it's blocking my field of vision, which actually is more dangerous than having the guard on. I don't understand actually what this is doing. Are we preventing something from falling from the sky here? I don't get it. So anyway, okay, enough ranting. Let's we're gonna move on to the grinder, okay? And I'm not gonna turn this off. I'm just gonna grab a couple pieces of steel here that I have set aside for the grinder. We're gonna move over here, and so I got a spot for this already. All right. And we're going to, oh shoot, where'd it go? so we're walking up to the grinder here. Now, a couple things. Move that. Okay. First of all, clearly my water's empty. So what do I need to do? I'm gonna go fill up my water. So got my water full, all right? And shoot, light's burned out, darn it. Okay. Now, if you read the textbook about grinders, when you first turn them on, it's gonna tell you that you need to step to the side and turn them on. And that is true. The reason for that is because of the way that these grinding wheels are formed, the way that they're made, is if you can imagine that this is the same thing, it's not at all, but if you can imagine this is the same thing as sandpaper, the rock, it's actually not rock, it's a silicon carbide or a silicon dioxide, is formed with adhesive and extreme pressure and heat. All right, so the wheel, the grinding stone itself is a whole bunch of sandpaper, garnet, sand, and then it's formed with adhesive and heat and pressure to make these wheels. Now, what can happen is that these wheels can develop a crack in them, okay? So what you want to do is typically, periodically, or you're supposed to every single time, inspect these for cracks. Now, if you were to miss one, now I've never seen this happen before in all my years, but they can explode, okay? And if they're gonna explode on you, because they're spinning, we've got centrifugal force, the particles, the shrapnel, if you will, is gonna go out, right? Boom, right? And if you're standing there, then it could hit you, okay? Now, I've never seen that happen. I guess it's happened quite a bit. But so when you turn it on, you want to step to the side, okay? And we're gonna do the same thing that we did on the disc sander. I'm gonna show you a couple different techniques, very basic techniques, and a couple things of what not to do. Now, so yes, let's real closely here. I don't know if you can, it's hard for me to look. You can see my gap is 16th, definitely a 16th and a 16th. That's pretty good, okay? That's real good. I do keep that gap close. I grind my lathe tools here, so my rests are trued up to the wheel and etc. Okay, so I'm gonna go ahead and turn this on. I step to the side. I'm gonna let it spool up, okay? And here's my material. So what I'm gonna do is I'm just gonna clean this up, okay? Nothing fancy. I don't really care about the angle. We're not, you know, see that angle? All I wanna do is demonstrate how to use the grinder effectively and safely. That's all, that's my goal for right now, okay? So I'm gonna come up here, I hope you can see that. And okay. And I'll come around this side here. I just want to clean this up. All right, and then after that grinding process, notice once again how little pressure. I'm not and pushing into this thing, okay? Really lightly. That's it. That's it. Okay? And now because of that grinding action, you definitely can't see it, but there's a little burr here. I'm just gonna knock that burr off. Okay? There we are. That's all there is to it. Okay? There we have it. We are done. Seriously, that's it. That's what the grinder's for. Now, here's a solid piece of metal. All right? And let's say, I'm not gonna go all the way, but let's say we wanted to put a 45 on here. Okay? Or not quite a full 45, but just a little bit. That's gonna take some work. All right, so I'm gonna go over to the coarser side first. And I'm gonna draw those lines in my mind like I did on the disc sander. And I'm gonna start grinding away at this material to put a small 45-degree angle in there, about like that. Okay, here we go. Notice that I'm using all of the wheel, right? I'm not just holding it on one spot. What's that gonna do? It's gonna actually put a groove in the wheel, okay? So I wanna use the whole wheel and keep it flat, right? All right, here we go. The dunk. Oop. I might have waited. Oh, look at that. I might have waited a little bit long on that. I can touch this. I can touch this. See that? The fine side. Quick little deburr action there. And there we have it. All right, so I'm gonna turn this on again. Okay. So here are some things not to do on the grinder. All right. First of all, I think it's pretty clear. Do not push this in and force it. Right? I mean, I think that's pretty obvious. Okay. Once again, we're going to be real gentle. Notice the way I'm holding this. I'm letting the grinder do all the work. Okay, now more what not to do. I don't do this. See how it bouncing? See how it wants to? See how it bounce? See it? Yeah. That's not good. Okay, you don't want to do that. So in order to do what I was just doing, say I wanted to clean that burr, we're gonna bring it down to the rest. Okay. No bouncing. Much. Look at that. Nice cut. Okay. All right. Now. Okay. This is where things get a little confusing. Now the textbook, or some people are going to tell you that it's not okay to grind on the side of the wheel like this. See? Now, what I just did, it would be much better to do here. You can just tell by the way that sounds. Much better. Okay. it actually is okay to grind on the side of the wheel, to put a thrust load on the side of the wheel. But you have to realize, okay, the thing here is, and I talked about it earlier, is that this is spinning, right? So we've got centrifugal forces coming out this way, okay? Now, if I introduce a load onto the side of the wheel, I'm fighting that centrifugal force, and the wheel is wanting to do that, and that's bad, okay? So if you want to grind on the side of the wheel, absolutely 100% of the time has got to be super light. So see that right there? Okay. All right. Yeah. So that's grinding on the side of the wheel. Actually, sometimes on some grinders, the rest actually extends back. This particular one, it does not. But they do extend back. But you got to know that you're fighting that initial force. You're introducing a thrust load, and that could blow up the wheel, or it could ruin the bearings. And anyway, I think I'm pretty clear on that. Clearly, don't move the guards. The guards are there for safety. Safety glasses is a must. The water is absolutely 100% necessary. Once again, no aluminum or soft materials. That's it. There you go. I think this is a great example of gloves. I mean, no way, right? Whew. Yeah, you're in trouble. Okay, gloves. That's a bad scene. All right, you're in some serious trouble. All right. Well, let's move on. Okay.